Chapter 6, Manures and Fertilizers by Daniel Dean. The supply of plant food elements present in soils will produce potato crops of varying size according to the climate, the original natural fertility of the soil type, and the degree to which it has been reduced or improved in condition since bringing under cultivation. Manures and fertilizers are used to add plant food in forms so easily and quickly available that the crop will be able to take up and use more than it could without them. On account of its tender nature, compared with other farm crops, the potato responds well to the use of fertilizers. Manures and fertilizers are used wherever the increased yield brings enough in the market returns to meet the additional cost and leave a profit. For these reasons, the use of fertilizers is more or less localized in the particular sections where their use is most profitable. For example, the cool and moist climate of the Aroostook region of Maine is very favorable to the production of large yields of potatoes to the acre. In spite of the great natural fertility of the soils, these fertilizers are used to the extent of over 1,900 pounds to the acre on the average at a cost of over $30. Remember, that's back in 1917. Because the practice pays. The great trucking region which supplies city markets from April till autumn and extends along the Atlantic coast from Florida to Long Island is nearly all made up of sandy soils of low natural fertility. The comparatively high prices received for this early crop makes heavy fertilizing, often over 2,000 pounds to the acre, profitable. By contrast, the irrigated sections of the Rocky Mountain region often have soils very rich in the mineral plant food elements, though often low in the supply of nitrogen. This is obtained by rotating the potato crop with alfalfa. This would render fertilizers of little value for these conditions, even if the high freight costs from our present sources of supply did not put fertilizers out of the question. Scientists are not fully agreed as to the functions of the different elements in the soil used by plants. Experiments have proved that several must be present or plants will not grow. The common term plant food is applied from these experiments. Fertilizers, so remember this is back in 1917, we know more about this now. Fertilizers have other actions of value to plants, some well understood and some which have only been discovered and are as yet not very well known. One is their favorable action on the beneficial bacteria present in the soil. That's the office of EXPT.STA Bulletin 194. Certain fertilizers, by rendering soil conditions more favorable for them, increase indirectly the fertility of the soil, as well as by their direct action. Our knowledge of these bacteria is limited at present in some directions, but it is certain that their importance to agriculture is very great, much greater than is generally known. One limit to the yield of farm crops is the amount of water which is available for their use. This is shown by the great gains from the practice of irrigation. Fertilizers practically increase the water supply by increasing the concentration of the solution of plant foods in the soil water and so enable the plants to secure more from the same amount of water in the soil. See USDA Bureau of Soils Bulletin 22. It is thought that to some extent fertilizers act as disinfectants to reduce damage by unfavorable agents in the soil. Fertilizer practices. Elements often present in the soil in too small quantities for the best growth are nitrogen, phosphorus, potassium, and calcium. When these are added in the form of fertilizers or manure, the yield of most crops is increased. The extent to which farmers may use fertilizers depends on the cost of the fertilizer compared with the net value of the increase in the crop. Another factor which must be considered is the residual effect of fertilizers on the soil. In the early days of the use of fertilizers, small applications were often made without much attempt to maintain the soil's supply of organic matter. When the amount supplied was sufficient only to give the young plant a better start, it is probable that the increase in yield removed more of the plant food elements than was added in the fertilizers. Being usually applied to grain or to tilled crops, there was but little increase in the amount of organic matter returned to the soil in the plant residues, not enough to replace that destroyed by the process of tillage. This has led to a strong belief among older farmers that fertilizers will run out the soil. The present tendency among potato growers is to use much larger applications which supply an excess of soluble plant food elements over those removed in the crop. Practice in the use of fertilizers was for many years based on the theories of the famous German chemist von Liebig. He taught that plant food must be returned to any soil to equal exactly that removed in the crop. The practical error in the assumption that the composition of a fertilizer for any crop is determined by the chemical analysis of the crop itself is that it does not sufficiently take into account the great natural stores of plant food in the soil, nor the biological conditions. The plant food needs of the growing plant at any time are not necessarily based on its final composition. The presence of a particular number of pounds of an element in soluble form somewhere among the millions of pounds of soil on an acre is no guarantee that the plant roots will be able to find and use it at the time when it is most needed. Growers in specialized potato growing regions like Aroostook County and the early truck potato section apply more plant food than the potato can be expected to remove in the crop. In order to make certain that it will not have to suffer for a lack at any time, the effect of this practice is seen in the subsequent crops. In southern trucking regions, the choice of the crop to follow heavily fertilized potatoes is largely governed by its ability to make good use of the fertilizer left by the potatoes. The longer experience of European farmers with fertilizers has resulted in England in laws by which the value of the fertilizers left in a soil by crops is computed. Under the tenant system, by which most of the farms of England are worked, an outgoing tenant must be paid by his successor for the unused fertilizer left. This proportion of the value of the fertilizers applied varies with different materials, being lowest with the soluble nitrate of soda and highest with such slowly acting materials as ground, bone, and lime. Market forms of fertilizers. Commercial fertilizers are found on the market in the form of many different materials, which are also manufactured into many brands of mixed fertilizers. usually being prepared for some special crop or soil. Both the materials and mixed fertilizers are sold under statement of definite percentages of the plant foods they contain. Annual state inspection and analysis show that these statements are usually reliable. Each has advantages for farmers' use. The mixed factory goods are usually in good mechanical condition for sowing and are generally kept or can be soon obtained from dealers. These dealers usually extend credit to buyers. The manufacturers contend that by the wet or acid process, they are liable to utilize materials too insoluble for use directly by crops. The many trade brands for the same crop may differ greatly in composition, and often a number of brands having the same analysis are sold as special fertilizers for widely varying crops. The variation between soils is so great that the same crop raised on different lands may require widely varying fertilizers for the best results. Only experience and careful study will show what these requirements are. Such study and observation are rather rare in America. In Europe, farmers are more accustomed carefully to mix their fertilizers according to the special needs of each combination of soil and crop. In Germany, this goes so far that the materials are often applied separately at the most favorable time for the action of each. Although this would not be advisable here on account of greater cost of labor, the materials used by farmers in home mixtures are usually of high grade. Sometimes, as with nitrate of soda, acid phosphate, and muriate of potash, a mixture that is of the right analysis for a particular crop may be composed of materials that are sticky in combination and do not drill well. Care must often be taken to include materials like dried blood, tankage, ground bone, and sulfate of ammonia that drill well. The cost of home mixing may be $1 a ton, more or less, sometimes under 50 cents. A tight wagon box or barn floor, screen, measure, and shovel are the only belongings needed if enough is mixed so that batches are made up of one or more bags of each material. If less, scales are needed. Dealers do not like to sell materials in small quantities, but by clubbing together, farmers can buy carload lots. Most of the phosphoric acid in factory mixed fertilizers comes from acid phosphate. The value is the same from any source if acid treated. If not so treated, as in tankage or ground bone, it is slower to become available. Most of the potash comes from muriate and kainite, which differ but little in their action. Some comes from sulfate. Fertilizers vary mostly in the value of the nitrogen. The higher grade factory mixed fertilizers are more certain to have high grade nitrogen than the low grade cheaper mixes. Before the Great European War, the prices of fertilizers had remained fairly constant for a number of years. The experiment stations in the northeastern states usually value the best grades of nitrogen at 15 to 18 cents a pound, soluble phosphoric acid in acid phosphate, and potash in muriate at about 5 cents. These prices are ton lots of the best materials bought for cash in large markets. Buyers of car lots usually purchase enough cheaper to cover the cost of freight to country points at these prices. Lack of knowledge of fertilizers among farmers has led to a failure to appreciate the fact that it is the cost a pound of the plant food which the fertilizer contains and its quality that determines the actual value of any fertilizer, not the price a ton. Many farmers look too often at the cheapest, regardless of the analysis. For example, muriate of potash contains 4 times as much potash in a ton as kainite and often costs less for the 1 ton than for 4 tons of the less concentrated material, making the potash cost less a pound. In addition to the saving in labor of hauling and applying, the cost a pound of nitrogen in high-grade dried blood, nitrate of soda, and sulfate of ammonia at $50 to $70 a ton may be less than in the cheaper grades of tankage and the like, besides being of far better quality. There is less variation in the price a ton of acid phosphates because the best sold in America seldom exceeds 16%. The relative cheapness of plant food and mixed fertilizers depends largely on the analysis. Mixtures of acid phosphate and potash are comparatively low priced and at the same time are of high grade and cheap for the amount of plant food which they contain. Nitrogen is so expensive that a small percentage runs the price up rapidly. Usually the higher grades of so-called complete fertilizers, costing $30 a ton or more, are relatively cheaper than lower grades, selling around $20 a ton. It is usual for the makers of the higher-priced complete fertilizers to claim that the nitrogen in them is in a variety of forms of varying quickness of solubility, thereby becoming gradually available to the crop through the growing season. This is something which should be considered by farmers in making up their orders for material for home mixing. Nitrogen. Nitrogen helps rapidly to increase vegetative growth. When nitrogenous fertilizers are extensively used, the foliage grows large and rank and has a dark green color. In extreme cases, the foliage may become too loose and open and porous in texture, and so render the potato plant more liable to the attacks of disease and sun scald. Lack of available nitrogen for the plant is shown by small size and light yellow color of the foliage. Commercially, nitrogen used in fertilizers comes from a variety of sources which vary greatly in value and in the quickness with which they become available. Nitrate nitrogen, the form to which other forms must be changed in the soil before the plants can take it up in the soil solution, is the quickest available. Nitrate of soda is the principal commercial form. It comes from deposits in Chile, hence the old name of Chile saltpeter. It is so rapidly soluble in water that it may sometimes be dissolved and lost to the plant if heavy rains fall before the feeding roots have had time to form. For this reason, it is either applied after planting as a top dressing or is used for only a part of the nitrogen of a mixture, the remainder being in slower acting forms. Because of this rapidity of action, nitrate of soda is particularly valuable for use in early spring, on early potatoes before the soil warms up enough for the process by which the other forms of nitrogen change to nitrate. It contains about 15% of nitrogen. Sulfate of ammonia, a byproduct of coke and gas manufacture from coal, is next in order of availability. It contains the largest percentage of nitrogen of any material, 20%. It has good mechanical condition for mixing or sowing. One drawback is that its use tends to make land sour and that it is not very efficient on sour soils. Nitrate of lime and cyanamide are comparatively new commodities being made from the gaseous nitrogen of the air by the use of electricity. While not extensively used, it is probable that in time they will become very important sources of nitrogen. Cyanamide is difficult to mix well in fertilizers and has other drawbacks. Much of the nitrogen of factory mixed fertilizers comes from organic sources. These are slower in their action as the organic forms of nitrogen must be changed first to ammonia and then to nitrate before the plants can take them up. Warm weather and warm soil are needed for this. Dried blood is the best of the organic forms, with tankage, fish scrap, and cottonseed meal also used in different sections. Other more slowly available forms like leather, animal bone, and horn meal are nearly useless to the potato crop unless treated with acid by the wet process to make them more soluble. In comparing the prices of any of these materials, the degree of availability must be considered as well as the price a pound of the nitrogen. It is unfortunate that state laws do not compel the statement of the percentage of each of the principal forms in which nitrogen is found in fertilizers, as well as the total. At present, the nitrogen in as poor a material as dried peat, often used as a dryer in mixed fertilizers, counts as high in the total percentage of nitrogen as from nitrate of soda or dry blood. Nitrogen is so much more expensive than the other elements of plant food and so easily lost from the soil that every effort should be made to conserve and increase the soil supply by the use of rotations which provide plenty of organic matter, including legumes, and by making soil conditions as favorable as possible for the different soil bacteria which take or change nitrogen. The other plant foods are in the soil in stable forms which are not easily lost. Nitrogen exists largely in very unstable forms which are easily lost in drainage water or by changing into the gaseous form of nitrogen. Phosphorus. Phosphorus, usually referred to under the name of its form as phosphoric acid, or P2O5, is often in very small quantities in American soils, even in those abundantly supplied with other elements of plant food. See bulletins by Hopkins, ILL, maybe that's Illinois, and Agricultural, EXPT, STA. Its actions on growth are not fully understood, but are very important and are becoming more and more appreciated. A deficiency in soluble phosphoric acid quickly reduces a crop yield. Unless a sufficient amount is present, plants do not mature properly. Its use tends to produce early maturity and is marked by dark green foliage. The principal supply for use in fertilizers comes from deposits in the south, which are supposed to be derived from fossil bones. When ground finely, this material is sold under the name of floats or raw rock phosphate. It is much used in the Corn Belt states and gives good results there on general farm crops. It is too slow acting for the more delicate potato crop and has not given very good results in most experiments in the colder northeastern states. Acid phosphate is made by treating this raw rock phosphate with sulfuric acid. This unites with part of the lime in natural combinations with phosphoric acid. Instead of the insoluble phosphate, in which 3 parts of lime are united to each part of phosphoric acid, there is formed the water-soluble form, in which only 1 part of phosphoric acid is united to each part of lime, together with a small proportion of the reverted form soluble in weak soil acids, in which 2 parts of lime are united to each part of phosphoric acid. The sum of these makes up the available P2O5. Acid phosphate is also made from animal bones, but the supply is only enough for a small fraction of all that is used. Acid phosphate is the principal source of phosphoric acid in this country, either for factory mixed fertilizers or for home mixing. The word acid has created a foolish prejudice against its use, which is not warranted by facts. A very small application of lime will prevent any chance of the soil becoming sour from its use. Ground animal bone and basic slag are valuable sources of phosphoric acid for some other crops, but are too slow acting for the tender potato. Different grades of American acid phosphates vary in the percentage of phosphoric acid from 12% to 16% or more. Only the highest grade should usually be bought. The price a pound of the phosphoric acid applied to the land is the real cost. In the northern states, the price a pound at the railroad station is usually less in the higher than in the lower grades, and in addition, there is the cost of hauling to the farm and applying to the land. 3 tons of 16% acid phosphate usually costs less than 4 tons of the 12%, and the cost of hauling and sowing the extra ton is saved. Potassium. Potassium, usually referred to as potash or K2O, is present in large quantities in most American soils. Some of the very sandy soils near the seacoast and the swamp mucks are likely to be deficient in it. Potash helps in the translocation of starch within the potato plant and tends to lengthen the life of the crop. Practically all the commercial supply of potash comes from deposits in Germany, controlled by a syndicate there. The principal form used in America is that of muriate of potash, containing 47 to 50% of actual potash. This is usually the cheapest form in which to buy potash. The chlorine in the combination with the potash has some tendency to make soil sour, and in some experiments. 1. Brooks, Mass. EXPT STA. And in some experiments has produced smaller yields and poor quality than when sulfate of potash was used. The latter, 47 to 49% potash, is more expensive and is but little used except for tobacco fertilizers. Kainit is a raw material of low grade, 12% potash, and is relatively higher in price. A pound of potash contained in most places on account of the freight on material of less value. Potash fertilizers are mixed in the soil after applications and are not likely to be lost by leaching. The solutions in soil water are rather caustic, and heavy applications are likely to burn the roots of plants if applied close to the seed. The old idea of mixing fertilizers, according to the chemical composition of the crop, has led to the use of fertilizers containing much more potash than practical experience of farmers and scientific experiments warrants. Mixed fertilizers often contain 7 to 12% of potash. A number of experiments by the Geneva and other agricultural experiment stations have shown that this is too high for profit. 5% is usually all that will pay. Potash is so abundant in most American soils that nitrogen and phosphorus are likely to be much more needed. Calcium. Calcium in the form of lime is seldom so deficient in American soils as to render its use directly necessary as a fertilizer for potatoes. In fact, very heavy yields of potatoes are often grown on soils too acid to grow clover. The potato seems to be very tolerant of acid conditions. Heavy applications of lime produce conditions under which the common scab is likely to injure the tubers. The powdery scab prefers acid soils and is reduced by liming. Let's see, tubers has a 1. That is VT BUL 184, probably Vermont Bulletin, number 184. There are other reasons which make the use of lime of great value. The other crops of a potato rotation are more likely to be benefited than the potato, and the net profit of the rotation as a whole must be considered. The clover and grass crops are the ones most benefited by liming, and these are the ones that do most to maintain the soil supply of organic matter. Heavy sods and other residues from hay crops bring up soil fertility rapidly at small cost. In this way, subsequent crops of potatoes are benefited. Lime is also essential for the action of the beneficial soil bacteria. Many American soils are now becoming deficient in lime. Lime should be added to soils in rotation in which potatoes are grown to as large an amount as the soil can use without producing scab on the tubers. What this amount will be can be found only by careful trial on every soil and sometimes on every field. Some soils can use several tons of limestone to the acre without danger. While 500 pounds might be too much on limestone soils or those in high condition of fertility, burned lime has been almost the only source of lime for many years. Ground limestone is now coming into use very rapidly, and it is probable that before many years will entirely displace burned lime in most places. It is much easier to apply, and its use is far safer. Burned lime is thought by some to have a tendency to use up the organic matter in the soil, even when thoroughly slaked before application. Hydrated lime is too expensive to compare with the others. Any form of lime should be applied to the crop in the rotation which follows potatoes, and should be thoroughly harrowed into the soil. Sulfur. Sulfur is present in all soils and is not likely to be deficient in any way. There is some ground for the belief that part of the value of acid phosphate is due to the sulfur contained in it. Applying fertilizers. The method by which fertilizers are applied to a soil often determines the profit to be obtained from their use. Nitrate of soda is so quickly and easily soluble in the soil water that it can be sown on the surface of the land at any time with the certainty that the first rain will dissolve it, or that it will quickly dissolve if mixed with the soil. Other fertilizers require weeks, months, or even years to become available to plants. A gradual evolution is taking place in the ideas as to the proper use of fertilizers. and that was back in 1917. We're still learning. In the earlier days of their use, when the quantity applied was limited to perhaps 100 to 200 pounds to the acre, it was rightly considered as only a starter for the young plants. It was applied to the soil close to the seed, being often dropped by hand. The roots, starting from the young plants, were certain to find a supply of readily available plant food as soon as they could use it. This would give a quick start to the young plant, which would enable it to grow more quickly to a size when it would be able to forage for itself. As the profits from the use of fertilizers became known, the amounts gradually increased. About the same time machine planters came into use, these applied the fertilizer in the form of a strip several inches wide in the bottom of the furrow mark. This wide strip application is essential to prevent root injury. Application with the planter works well whenever moisture is abundant in the soil throughout the growing season in Maine. As the amount applied to the acre increased to 1,000 pounds or more, growers began to use a wider distribution through the soil. With such large amounts, there is no need of specially placing some of it near the plants, as a fraction is enough to act as a starter. At the present time, heavy applications of fertilizer are used in the specialized potato growing districts in this country, with the idea of supplying so much that the growing plant will never suffer for lack of plant food at any time. For such amounts as 1,000 to 3,000 pounds to the acre, broadcasting is coming into use in whole or in part. Ordinary grain drills or special broadcast fertilizer sowers are used. All fertilizers broadcasted should be thoroughly worked into the soil. While there is some tendency for soluble fertilizer, salts, to work downward into the soil, there is likely to come any summer after potatoes are planted, a hot and dry time when several inches of the topsoil is very dry. The fertilizer in such a dry soil is practically useless to the crop for lack of sufficient water to dissolve it. This is especially true when a surface mulch of dry soil is maintained for the purpose of conserving the moisture in the earth below. This accounts for some of the contradictory results obtained by experimenters on comparisons of the application of fertilizers by the drill and broadcast methods. Under the conditions of northern Maine, in which the water in the soil is usually abundant, part of the heavy fertilizer used is often put on after the plants are up. Being applied to the ridge and covered with soil, it is doubtful whether this method would be a success in other regions, even in some other parts of Maine. That's Maine Agri, that probably agricultural, EXPT STA BUL Bulletin 246. Unless soil moisture conditions are fairly certain to be favorable at the time of the second application, nitrate of soda may be applied at any time, as it is so easily dissolved. Success with any method of applying fertilizer depends on soil moisture conditions. The correct method in one case may be entirely wrong in another. The writer has developed, for his own farm conditions, a method which has been very successful for applying large amounts of fertilizer. The soil is a silt loam of good water-holding capacity, further increased by the incorporation of large quantities of organic matter. The total rainfall for the whole year averages under 30 inches. Periods of dry weather after planting sometimes extending to several weeks, keep the surface soil very dry. In some fertilizer experiments, acid phosphate applied as a top dressing after planting did not become dissolved to produce much increase in yield. At the same time, when it was applied deeper in the soil before planting, a good increase resulted. The soil is deep, and potato roots easily penetrate to the depth of several feet. The fertilizer is usually 1,500 to 2,000 pounds of a mixture of acid phosphate and muriate of potash. Part of the fertilizer is sown, broadcast in early spring on the surface of fall plowed land, thoroughly disked in to the depth of 7 to 8 inches and the field replowed to the depth of 10 inches. The remainder of the fertilizer is then applied and disked in as before. The essential idea of this method is to have a large amount of fertilizer so evenly and thoroughly distributed through the soil to the depth of 10 inches that the potato roots are drawn out and down completely to fill this whole space, rather than to have a tendency to remain in the more limited space occupied by the fertilizer when either the drill or the broadcast method of sowing is used. Scientific experiments show that roots multiply mostly in the soil where the supply of plant food is most abundant. That's Storer, quote, Agriculture, unquote, Volume 1, pages 297 to 300. In reference number 2, that'll be NEB AGR EXPT STA Bulletin 146 and Colorado AGR EXPT STA BUL 216. And reference number 3 will be from the Bureau of Soils, Bulletin 22, page 52. The surface mulch of dry soil keeps the lower parts both moist and cool. Later, the heavy tops shade the ground with the same result. This cool lower soil, although itself too dry for roots to grow in, is a marked advantage in hot seasons in preventing degeneration of the potato as well as in increasing yield. This method of applying fertilizers has produced very striking results in dry seasons. In periods of extreme drought, the top showed but little injury from tip burn and grew continuously. The writer thinks that this success is due to the greater moisture supply made available to the plants by the wide and deep distribution of the root system. This enables the plants to find and utilize the water in a larger volume of soil at the time when the plants need it most. When the roots are encouraged to develop near the surface by broadcasting the fertilizer and working it in shallowly, the drying of the upper soil layer deprives the plants of the use of much of their root system and may leave them in poor shape to withstand hard conditions than if the roots had been forced to spread out and down earlier to find plant food. In the Corn Belt, dry weather in June is recognized as a favorable factor for the future success of the corn crop because it forces the plants to root deeply, while a wet June would result in shallow rooting, which would be certain to suffer later in the summer. Farm manures. Farm manures increase the productiveness of the soil in 4 ways. First, by the actual plant food added to the soil. Second, by the physical effect of loosening and aerating the soil and adding to its moisture-holding capacity. Third, by the action of the organic matter of the manure in making available to the plants, by its decay, the insoluble plant food of the soil. and fourth, by improving the soil conditions for the work of the beneficial bacteria. Any computation based on the trade value of the plant food may be falsified by the other values being even more important. A better way is to consider the results obtained in farm practice by particular crops through a series of years, long enough for the residual effect of the manure on the soil to be measured. The potato usually responds well to the use of manure throughout the humid sections, and the increase in yield of a cash crop like the potato gives quick returns for the use of the manure. There is some danger that common scab will be worse on potatoes grown on land heavily manured. This danger is reduced by using smaller amounts, by having the manure rotted, and by spreading some time before planting. Horse manure is thought by some to favor scab more than other manures, but this is doubtful. Manures are poorly balanced fertilizers. They contain relatively much more of nitrogen than of the other plant food elements and are likely to produce plants with large growth of tops without corresponding tubers. This can be prevented by using with the manure 50 pounds of acid phosphate to each ton, and in rare cases potash may be added also. Coarse and strawy manure may make some soils too open and porous, causing them to dry out, particularly in dry years and dry climates. A practice in handling manure that is gaining ground is to apply it to the hay crop preceding potatoes in the rotation. By increasing the yield of the hay, the organic matter left in the soil by the roots, stubble, and aftermath is increased for the use of the potatoes later. When manure is applied directly to the potato crop, it is better spread in the previous fall or winter than just before plowing. The manure spreader does better work than hand spreading because of the practical impossibility of getting as even distribution with a fork as with the machine. Unless the potato grower has only a small area, it is more profitable to give the whole a thin coat of manure than to have parts heavily covered and the remainder without any. Experiments extending over many years show that the profit to a ton decreases as the size of the application increases. The manure spreader has an advantage over hand spreading in this respect because smaller amounts to the acre can be spread evenly. The value of farm manure is greatly reduced by poor methods of handling. The best net returns from its use come from spreading as soon as possible after it is made, when necessary to keep it for some time, as when fields are occupied by growing crops in summer. Precautions should be taken to prevent loss. Exposure to rains may leach away half the value in a short time. By heating in piles, much of the nitrogen escapes. Keeping under cover prevents leaching. Keeping in shallow piles, tramping by animals, and occasional wetting prevents heating. Land plaster and other substances are mixed with the manure to prevent the loss of nitrogen. Raw rock phosphate, or floats, is valuable for this purpose in addition to its phosphoric acid, the element needed to balance the manure as a potato fertilizer. Acid phosphate is valuable for this purpose, but it must not be used under the feet of animals. Manure spread in the winter suffers no loss from heating and but little from leaching, unless the field is so sloping that water runs off rapidly. It is so difficult to prevent loss in manure kept in other ways that spreading as rapidly as made is the best method in most cases. Reference: Volker and Hall, The Valuation of Unexhausted Manures.